Yes, good morning. So I'm Baptiste Girard, working in the network automation team at Expereo. And today I'll explore how we built our source of truth and how we managed to derive value from it. 2 words before we start. I really focus this presentation on more the use case and the business aspect of it, and not too much on how we actually built this. So if you have any question, I'll be around. I'll try to spare some time at the end. And yeah, let's get started. Few words to say to kind of set the background before. Who is Expereo? So we are an internet service provider. So we offer a wide range of services from regular DSL link to broadband access and all the way to SD1. And we offer that globally. And so among all those products, there is one which is going to be the silver lining for this presentation. It is called Enhanced Internet, and for that particular product, we operate more than 30 data center locations across the globe with core routers, core switches, connected with multiple transits in order to create this redundant setup. Next to that, we are in our proprietary routing optimization software, reducing packet loss and latency for the traffic reaching the internet. And so that creates this highly available and optimized platform where we plug customers so they can benefit from this enhanced internet access. All right, so looking back at the situation a couple of years ago, we had scattered data across different places. Quality was rather bad, to say the least. And so to give you an example, every time we provision a new customer service, we allocated a VLAN. And so it was a fully manual operation for delivery people to browse through the IPAM system, try to find the right VLAN, create the VLAN object, and they were basically dropping this service reference directly into the description. So that's what I would call a weak link between IPAM and CRM, as it's only relying on this free text field. So there, we try to build some reports on top of that. And as you can imagine, there is a lot of steps of getting all these VLANs, getting the description. Maybe there is something that looks like a service ID inside it. And so we can query the CRM, get this service status we are looking for. And so we have our answer to our question, which is, do we have any VLAN related to a service which is canceled, for instance? And so doesn't scale well, really difficult to develop. We also try to automate some stuff of some step of the processes. So there, for instance, I'm looking especially on the support side, as they need to investigate and fix customers' issue as fast as they can to not breach SLA and all these things. And there, pretty much same limitation, really hard to develop, really hard to maintain. And with that data set, it was only working in a few very particular use cases, and it was not reaching the full potential we wanted to have. So I think beyond all that, what was really harmful for us is, as all the operation performed on the data were fully manual, we never had this control, and we never had this layer of reports around to assess the quality of the data. Basically, nobody was trusting it. So everything we built on top of this sketchy foundation was pretty much facing the same issue. Nobody was trusting it, and so nobody was adopting what we were building there. So the adoption rate was very low, on top of being really painful to develop, scale, and maintain, and so on. So at that step, we decided to take a step back and to start from the data first. And so to help us, to guide us into this journey, we set a North Star. So basically a few areas where we want to see some improvements. And the first pillar here is asset management. So I would summarize this as our capability to understand what is running where, with which version, and under which IP. Second pillar, lifecycle automation. As I mentioned, everything was done manually, from delivery to activation to support, And so there is a huge potential for automation, and we want to bring this automation there. Last pillar is to make this data accessible. So there, it consolidates a bit this concept of single source of truth, sharing data internally with automation, reporting, you name it, and especially in our use case monitoring, as we don't want to inject the data at different places there. And also externally, as we have this product called Expereo, which is, to put it in simple, web portal for customers to view details about the services from delivery status to billing or potential incidents ongoing on the network. And so there we want also to bring the capabilities and the data we are building here directly into the customer hands. So that's the make data accessible. All right, so now, as we move on to the first big session on how we build our source of truth, first question we ask ourselves is, who is doing what with the data? And so here, at least the outline is rather simple. We have a first team, which is called infrastructure, and their mission is to really manage the core. So operate all those routers and switches, make sure that circuits are connected and that the whole thing is running smoothly. Second team is called service activation, totally separated from the first one, and their mission is to connect new customers onto the platform. So really they bring this last customer segment there. So with that in mind, we move to the actual meat, network data, and by network data I mean everything from IP address to device and all in between, VLAN and so on. And so there, as I mentioned, we had this scattered data. So we had to consolidate them into a new repository, and there we picked Nautobot as a source of truth. And so our mission was to get this data there. To get there, we basically define a strategy of creating a pipeline, getting all this data from these different places, and just throw them into Nautobot. We just see what sticks, and we fix what doesn't stick directly into the source system. And so to implement this pipeline, we used a Python library called diffsync, allowing us to load this data set, compare them from source to destination, and so we can compute the differences that needs to be applied on the destination data set. We then encapsulated this diffsync logic into a Nautobot plugin called SSOT, so it gives us the possibility to run the playbook directly from Nautobot instance, and also it gives this nice overview of logs and analytics, giving us the exact data which are failing there. So I think, yeah, we went through this process, and the few things we learned there is that first one, we need to have a really in-depth understanding on the data. So to give you an example there, we had in our legacy IPAM a provider object with a support portal field, and Nautobot has the exact same setup. So we thought, okay, this is going to be a slam dunk one-to-one mapping between the two. It's going to be easy. And it was the case. However, Nautobot is expecting this field to be a valid URL. So you know something starting with HTTP and so on. And it was not the case in our legacy system. It was just a free text field there. So we were receiving anything and everything. And so we had this incompatibility between the two different data sets. And so that's something we had to fix. And that's the transition to my second point, is that you need to have operational teams fully onboarded in the process, fully part of the migration team, as they have the business knowledge to fix this data. They know what is supposed to be there, and they understand the business to fix it. So with that, we eventually managed to migrate all this data into our Nautobot. So that's kind of the numbers you see here. And yeah, that has been a long process. And now we have this data rather clean, structured in our Nautobot instance. And so as we tackle this topic, there is a second one that popped up, and that is maybe the most important slide of my whole presentation. It's related to service definition. So I would summarize this as our capability to link some technical assets to a business representation and to reflect that these objects are building block of our service. So there, I'll divide this into 3 main stages. First one is the service, so the customer representation, if you prefer. In our case, it's rather simple as we sell this product externally. So we already have the BSS sales team and service delivery people working on the BSS layer. And so we have this service object, which is capturing exactly what we want here. Second step, the structure. It's basically we have multiple components to build this service. We usually have one VLAN, one IPv4 prefix, and one IPv6 prefix. And so there, as part of our custom plugin, we extended the out-of-the-box data model to create this relationship between service object we created and these different components. So at that stage, we have our service object, we have our structure to reflect this. We miss still the data on the service object. And so there, again, using a combination of this sync and SSOT, we got this data set from the BSS layer on a daily basis. So we get this huge list of services directly into our source of truth. Last step, and not the less, is lifecycle. Every single object has this status field, but most importantly, I think, is the service status. So there, we get this as part of our daily synchronization as well. So we see this status object, this status field, sorry, evolving over the time, so from new to in delivery to active and sometimes canceled. So at that stage, we have our actors, we have our network data, and we have the capability to link this network data with some actual service we are selling to the customers. So it's now time to leverage this and to get the actual value out of it. And as we move to this part, the first topic we addressed is customer provisioning. So there, as I mentioned, it was a fully manual operation before to scaffold all those services and so on. And so there, again, using Nautobot capability, we put together a form. And this form has a few interesting characteristics. First one is that it follows the life cycle. So here you see there is a small service input. And this input is not a free text field anymore. This is an actual object you pick here. So you're going to have a drop-down list with actual service object you can pick. And you won't be able to pick any service. It must be a service which is where the status is in delivery. So you won't be able to pick a service which is canceled. You won't be able to pick a service which is active. And so with that two things in place, we already mitigate a lot of issues when it comes to attaching assets with the right service. Second interesting one is that it follows the service structure. So there, as I mentioned, we have 3 main components. So it's going to allocate one VLAN, one IPv4 prefix, and one IPv6 prefix. But it also enforces this within the component itself. So for the IPv4 size, we only provide 28, 29, 30, 31, for instance. And that's the only option you will be able to pick here. No more, no less. So we are sure that this is what we're going to have at the end. And I think more importantly is that it creates this interface between the user and the data, which brings this extra layer of control I already mentioned, but it also creates this consistent input of data into the system. So we are sure that using this form, all the services which are going to be entered into the system will follow pretty much the same shape. So that's a good one. And also on top of that, it creates this small gap for us to implement more advanced features. So we have this small space, and there we introduce, for instance, an algorithm to avoid prefix fragmentation. When we allocate these small prefixes, we don't want to get them in the middle of the prefix, so we want to find the perfect spot to allocate them. And so that's what the algorithm is doing, and this is running behind every single form submission, so we are sure that we optimize a bit the way we allocate prefixes there. That's a simple one, but that's already a good step toward a better asset management. So now that we have this consistent way of scaffolding the services, and that with just a matter of minutes, a new service could be, at least the data part, could be allocated in the system. We now kind of fix the problem at the entry, so we can now assess what's already in the database. So now that we fix the entry, we can see what's already in there is looking like. And so to do so, we develop a small reporting stack. Again, there we leverage Nautobot job capability to query this data, compute it, and basically put together the indicators we wanted. And we plugged our Grafana instance on top of it. And so by running this job on a regular basis, we get point in time that we can plot in our Grafana instance. First report, interesting one, is related to lifecycle. So basically, we ask the data set, do we have any asset attached to service which is canceled, for instance? And that shows some great result in our case, as with that simple query, we managed to retrieve thousands and thousands of public IPv4 addresses, so these really critical resources that were hanging on there attached to services we were not billing anymore. So it retrieved all these assets, put them in a pool, ready to be used for an upcoming customer service. Interesting one also is utilization reports. So there, it's kind of the capability for us to assess the platform utilization. And to give you an example, now with the data set we have, to put the background first, we do not provide last mile toward the customer premise. So we use providers to do so. And so we have circuits to connect us with those providers and indirectly with the customers. Now with the data set we have in place and the data model we have here, we can list every single services connected through a given circuit. And so we can aggregate every single service bandwidth and compare it with the CDR we have on this circuit. So the committed data rate we have on this circuit. And so that gives us a contractual utilization of our circuits. And this is key. This is key when you want to put together some policy on we don't oversell our circuits. You need to have this kind of data to back you up on these policies. Or if you want to oversell 200% your circuits, that's what you need, this contractual utilization. All right. So this is pretty much where everything comes together. These two teams, they need to collaborate in order to answer this question, which might sound simple, but which is really complex, and which is, can we connect a new customer on a given location? And so we can break down this into some smaller questions. First one is going to be, do we have the IPv6? Yes, we have plenty of them, that's fine. Second one is, do we have the VLAN? And this one is a bit complex, but do we have the IPv4? This one is even more complex. And so that's the schema you see here. We have plenty of what we call container prefixes on a given site. And so this is basically big/24 we use for different things. Might be internal routing, might be internal services, and also customers. And so here, if we only put together a global IPv4 utilization report, it's not really relevant for the question we're asking, because we don't want to have customers next to internal services on the same IP space, right? So we need to find a way to differentiate these containers, the one we can use for customers from the one we use for other things. And so there we just introduce a simple tag that infrastructure team is applying on those containers that can connect customers. And so then we leverage this tag with our reporting stack to just get this per site utilization of those containers. And so we give this to infrastructure people so they can proactively scale the infrastructure. And that before we reach the 100% utilization and we can't connect customers anymore. And we go through the whole escalation process because the pipeline is stuck and so on. And so that allows them to allocate this new prefix, create the routing that needs to be happening on the network, and create the prefix in the database, apply the tag. And on the other side, service activation people, they have this form. And this form is only looking to prefixes with that particular tag. So with that, we are 100% sure that no customer is going to end up on the wrong IP space. And also, we have this consistent and efficient way to answer the question of, can we connect a new customer? All right. So a few words about the next step. We extended, again, this data set I presented here with more focus on the CMDB side, everything revolving around device, basically, and with a special highlight for to improve the security reports we have, because this is becoming a huge topic within the organization, I guess also more globally within the industry. So that's what we are working on right now. Second one is network automation, at least the configuration part. I'm not going to dive too much into the details, but there we managed to automate, to generate at least core switch configurations. So that's already a first step. We are working on core routers configuration. It's a bit more complex, as you can imagine. And so there we see, again, the same topics coming back of service lifecycle, for instance. We might have a VLAN which is in this reserve status for months or weeks. And there, it's never going to reach the network. But as soon, at the very moment where the service gets activated, and so this VLAN moves to the active status, there it's going to be part of the next batch toward the network. And so here we enforce also this lifecycle in our automation stack. Last is, I mentioned earlier to make this data accessible. So we have this GraphQL API that we maintain internally, and we are looking to extend it with what we are building here on our more network side. And for the one out there familiar with GraphQL, you have this whole concept of stitching and federation and so on. And so here, the way we introduce this service object directly into our source of truth, it allows us to do this stitching between the BSS, more business-facing schema, with what we have on the network side. So we can jump from customer, sites, accounts, services, and then we jump into the network side, VLAN, prefixes, IP addresses, and this is possible because we have the service object, and so we use that to pivot from BSS to OSS, basically. And so before wrapping up, I'll give you a few nuggets of information related to things that really work well on our side, at least. First one is service definition. The way we really rooted this service object deep down our source of truth, it allowed us to do all these cool features I mentioned here, plus some of them I haven't mentioned. But yeah, and I think beyond that, it allows us to highlight to the whole organization that we are directly enabling the business. And that's key when you want to have budget, when you want to have leverage in the organization to invest in such topics. Second one is data. I think if I have to give a rough estimation here, I would say we spend somewhere around 80% of the time and effort on really shaping the data, getting the data clean, structured in a proper format, and maybe a small 20% to get the actual value from it. And that's something that everyone needs to understand, that there is kind of an investment component to that. The more time and effort you're going to put in the data, the more value you might be able to get down the line, and the might is important here. And this is the perfect transition to my last point, is that this is also an organizational change. So there is definitely a technical component of developing these features, creating this integration with the network and shaping the data and so on. But more importantly, at least in our use case, the main challenge we face is definitely the organizational component. How do we make sure that the whole organization, from MT to operation to IT to everyone, embrace the change and is pushing in the same direction? That's a tough one. And so there, basically, to give you an example, operational team, they need to have the time and they need to have the resources to do so, to carry these changes, because I mentioned data cleanup earlier. This is something that falls on the side. But also, as we introduce more control on data and more automation, they need to basically review and change the way they operate. And that takes time, and that takes effort to do so. And so if the only objective they have is to push as many services as they can by the end of the month or by the end of the quarter, most likely they're not going to have too much time to invest in such projects, more long-term and not really fundamental projects. So that's the kind of message we are trying to push on a daily basis, for everyone to embrace the change, to shape the way we want to work on, more relying more on the system and the data. And so, yeah, if some of you there are facing similar changes, I hope you found some interesting bits of information and maybe some idea to bring back home. Thank you.
Okay, so being a service provider, do you use any automation for things like forecasting IP consumption or things like that? So like at our current consumption rate and our sales, we would exhaust our IP space at a certain point in time, things like that.
So we also, there is a part of our reporting, I mentioned Grafana, there is a part of our reporting happening on MicroStrategy for the more business-oriented things. And so there we try to, so we have our IP utilization, as I mentioned, and we try to have a forecast part, so using out-of-the-box features from MicroStrategy there. And it's slowly showing some great and interesting parts, because at the beginning we had no history on the data. And now that we have more history, the tendency, the graph is looking better now. So that's something which is, interesting one.
Okay, so yeah, I recognize, it was like listening to a version of me, but in French. It was amazing.
Pardon my French.
Yeah, close enough. So the question would be, you created the services plugin, right? So inside of Nautobot, did you have that cold shower feeling the night before? Oh yeah, we're going to build a plugin, and then we're going to run into maintenance hell. And should I tie this together on the layer above? Why did you tie the service together on the Nautobot level instead of abstracting away to the top? I went with abstracting away to the top because I'm terrified of the idea of running my own plugins, just because upgrade cycles are a nightmare already, and the scripts are hard enough. So yeah, we did a very similar thing. It's nice to see that somebody did a very similar thing when it comes to the service allocation, stopping the network monkeys from allocating a /24 every single time. Stuff like that is very resonating. But did you have a, what pushed you over the edge to make a plugin, or was I just the one that was scared of doing plugins?
I think it's a way to extend the data model there. Mm-hmm. Definitely, it's a big change for us on how we can bring this flexibility in the schema, in the data model, because basically so far it was a simple one. It's really simplified. We link IP prefixes, we link VLAN, that's fine. Then you start creating IP addresses under your prefixes. Do you link them to your service, or do you assume that it's under the right prefix, and then so you can find them back there? Do you have VRF? Do you allocate them on the service? Do you allocate them on the account, which is one step further? That's all the questions we are facing now, and that's all the things we need to take into account when extending this data model. So do we want to have everything linked to anything? That's a balancing thing to do here, and to be honest, I don't have the answer. So far, this is what we did. We only link prefixes, VLAN. We also do with devices, and there we assume that, interfaces, we know on which service it's linked because it's linked to the device, which is itself linked to the service. But yeah, that's a tricky one.
So yeah, the real power is you were able to map your existing business process to the data that you were working with and extend it. So and you got a lot of value out of the box.
Please use the microphone. We can't hear you.
But yeah, thank you for answering.
Okay, thank you so much.
Thank you, Scott.